now we are ready for an applications. We're going to do an application of a composition and an application of a combination. And the combination one you have already done a few times, so it shouldn't be a big shock. The composition, a function of a function. It says a stone is thrown into a pond, creating a circular ripple that spreads over the pond in such a way that the radius is increasing at a rate of 3 feet per second. So if you imagine tossing a rock into some water, there's the rock you toss, and it sort of creates this ripple effect, okay? And so maybe it looks more circular than mine does, but it's talking about how the radius is getting bigger, and it's getting bigger as time goes on, as the ripple spreads out. And so it says, A, find a function r of t for the radius in terms of time. Okay, the radius is not fixed, it keeps changing as time goes on. So r of t is equal to, it says that it is increasing at a rate of 3 feet per second. So it's equal to 3 feet per second, or 3 times t, where t is in seconds. This is how we could describe the radius. Now, then it says B, find a function a of r, the area as a function of radius. Well, the area of a circle, let's recall what a circle is. Here's the radius, right? And the area of a circle is pi r squared. So this is pi r squared. And so then it says find a of r of t. So a of r of t. So what we have here is, this is a of r, really of t. Or this is a of r, but really radius is a function of t. So this is a form of combination of functions. Again, in this particular instance, let me do this in red. I do not want you to get real anxious or worked up, but I want you just to have seen it before. Radius is a function of time. R of t is 3 times t. Area is a function of radius, pi r squared. So what we can do here is we can find the combination a of r of t, a function of a function. And so when we do that, that's going to be pi, and instead of putting in r, we're going to replace it with what r of t is defined to be, 3t. A of 3t. And so 3t squared is what that's going to be. So that is how we can use a function of a function. Then we say 3 times 3 is 9, t times t is t squared. This is going to be 9 pi t squared. All right, that's just a quick illustration of a way you could apply a composition. They're applied in many, many other ways as well. Okay, let's look at the last one, an application of a combination. Okay, this is one you've seen before. It has to do with money. So profit is what you get to keep at the end of the day after you've paid your bills. Revenue is all the money you have come in, but you don't keep all of that. You get all the money revenue that comes in from your business, and then you have to pay for the cost of running your business, employees, supplies, maintenance, electricity, whatever. And after you've paid off those bills, that is your profit. So that's basically what this says. In economics, functions that involve revenue, cost, and profit are used. For example, suppose that R of x, C of x denote the revenue and cost function of a grocery store. Then find the difference. Revenue minus cost is what profit is. So we have to find the profit function, and then they ask us to do something with it. So this profit is equal to revenue minus cost. This is the subtraction of two functions, or a combination of functions, right? That's what this is. Profit is revenue minus cost. And so let's find it. They said that the revenue is 60x minus 0.4x squared. R of x is 60x minus 0.4x squared. And cost minus the cost is 3x plus 13. So this is what our profit equation is going to be. Let's simplify this. Remember, this is really critical. Distribute that negative to both of these terms. So it's going to be minus 3x and a minus 13, just like that, okay? There's a 1 in front of this, so nothing has to happen there. These stay the same. So this is negative 0.4 x squared. 60 minus 3x is a positive 57x minus 13. This is our profit equation. That's the first thing we had to do. And then it says, A, find P of x. Okay, we did that. B, find R of 100. Okay, what is R of 100? What is C of 100? And then they want us to find what is P of 100. What does this mean? What does X represent? X represents the amount of tools that are produced. So R of 100 is the amount of revenue you get after you've produced 100 tools. C is the cost of producing 100 tools. And the profit is how much money you keep after you've produced and sold 100 tools. So let's just figure this out. R of 100, where's R? This is it. That's going to be 60 times 100 minus 0.4 times 100 squared. So that's going to be minus, this is going to be 1, 2, 3, 4. 1, 2, 3, 4. It's 6,000 minus 4,000. The revenue is 2,000. That's how much we bring in. That's what R of 100 is. Okay, what is the cost? It is 3x plus 13. So it's 3 times 100 plus 13. It is 313. That is the cost of producing 100 tools. What is the profit? It is simply the revenue at 100 minus the cost of 100 minus the cost of 100, which is going to be $2,000 minus 313, or 1687 if I subtract it correctly. That's how much profit you keep after you've produced and sold 100 tools. You've paid your bills, and this is what you get to keep. We could have also found this number by plugging it directly into this. Remember, there's 2 different ways to do that when you're given a value in a combination. Let's see. Was there something I missed here? Let me make sure. A of R of T. Let's go back to this stone being dropped. What does R of T represent? Let's make sure we understand what this means. R of T is the radius at some time T. So when T is 2, for instance, what if T is 2 seconds? That is the radius of this circle, or the ripple in the pond after 2 seconds have passed. So R of 2 would be 6, or 6 feet. It's 6 feet, the radius is 6 feet after 2 seconds have passed, after you've tossed the stone in. Well, what would be A of 2 when T is 2? That would be the area of that circle after 2 seconds had passed. That's what A of R of T would give you. So, all right, I just want to make sure I got that in. Okay, a couple of examples of compositions and combination of functions.